this computer. Okay, I'm going to put us on the collage view so we can do everything like that. Okay, Organic Chemistry 2341. We're approaching finals week. This will be our last Zoom telecom that's live for everybody. If you have questions, go ahead and email me. We can set up private Zoom lessons for individual topics, and so don't be afraid to go ahead and do that. So the first thing I want to say is that we somehow made it this far. Let's keep going. All right, so a little bit about the final. First of all, it will be administered on Sapling, since everybody seems to have access to Sapling and everybody seems to be signed up for the correct class. So it looked like the best way to do this. It will be Wednesday, May 13th at 8 a.m. to 10:30 a.m. You'll have the full 2.5 hours unless you already have an ODS request, and then you'll get the time and a half that is suggested. It will be 50 questions, multiple choice, 2 points per question, okay? Now, the way Sapling does it is that A, B, C, and D might not all be in the correct order. So be sure to read the question and look at the answers, because it randomly scrambles the answers so that A might be on D and D might be on A. So you need to look for the correct answer. I'm trying to not do that, but right now it's frustrating. It's fighting me. So I'm hoping to get that fixed. But you also can answer a question, continue on, and come back and re-answer the questions. You don't have just the one chance to answer a question. You can go back and review. And you will not give you feedback as to whether you got the answer right or not. All it'll do is say that you have completed it, and when you close it out, it saves everything. I think there's a save function or submit button. Go ahead and make sure you do that, just like whatever the instructions are there. I'll double check and make sure I email out instructions the day before if there's anything different than what I'm saying here on this video, okay? So Wednesday, May 13th, 8 a.m. to 10:30 p.m. No, I'm sorry, 10:30 a.m. to, I'm sorry, 8 a.m. to 10:30 a.m. 2.5 hours, that's all you get. Okay, and for those, this will obviously be posted on the web, so you can come back and take a look at it. Okay, so that being said, I wanted to give you some advice on preparing for this, because it is open note and open books. That doesn't mean you shouldn't study, because you won't have time to look everything up as you go. So the idea would be that you create review sheets for yourself to help you be able to answer the questions correctly. In these review sheets, it's basically, you're writing your own table of contents for the entire course. You can put where the notes might be or where it might be in the book on the side, and that is fine. And it's just to make sure that you are, fully prepared to answer the questions in a allotted amount of time. The questions are not just simply yes or no. They require some thought. A lot of times, because I have no drawing on Sapling, because one errant bond and it counts it wrong even if it's right, I will have questions where I put the structure in name form. So you actually have to draw it out yourself, figure out what's happening, figure out what the answer is. And so you'll need to have some spare paper around and be able to translate, nomenclature into structures, structures into reactions, and reactions into products, and then pick the correct answer. So make sure that, you have some spare paper set around. So the practice sheets I think you need to build are: 1, nomenclature, okay? That starts all the way back in chapter 2 with longest parent chain, and then numbering, alphabetization. Di-tri tetra is not part of alphabetization, only the group is. Rings take precedent, etc. And then as we got all the way up to chapter 11 actually had us where alcohol changes the name of the word, but ethers don't. Ethers are substituents. Make sure you have all those nomenclature rules. We should have a total of, including rings, there should be approximately 15 to 17 nomenclature rules, including RS, EZ, and cis and trans. Okay, so those are all part of nomenclature rules as well. All that should be on your nomenclature sheet. Okay, The next thing I think you should have is a sheet that has both bonding and properties. Okay, what we learned about, especially in chapter 11, is that the hydrogen bonding of the alcohol changes its properties more than anything else, because that hydrogen bonding raises the melting points and boiling points. So kind of giving a trend of what types of forces give you which types of properties. For example, the more linear hydrocarbon chain is, the more likely it's only to have induced dipole, or van der Waals forces, and therefore they have low melting points and boiling points. As you get to things that are cis and trans, that changes your properties slightly. And the more spherical something is, the fewer interactions it has, therefore it actually lowers the boiling point and melting point. So that kind of a general property sheet. And on that same sheet, you should have something about bonding, okay? On the bonding, I'm thinking more of what is it like electronically? So like, for example, water is tetrahedral electronically, because those are sp3 hybridized orbitals here, but structurally, molecularly, it's bent, okay? So kind of knowing hybridization, sp, sp1, sp2, sp3, those are important. Knowing the shape, both electronic shape, because lone pairs are part of electronic shape, but molecular shape where lone pairs are excluded. So those kind of things that'll help you identify, that's all goes down to bonding. How many electrons are in a sigma bond? How many electrons are in a pi bond? What orbitals are involved in a pi bond? These simple things are, I try to hit making sure I talk about hybridization at each carbon center. For example, when we moved to ketones and aldehydes, those were sp2 hybridized, so they were trigonal planar. When we moved to alcohols, they're bent because tetrahedral electronically, but bent molecularly. And that's in the book. So those are things that should be on the bonding sheet. And then our last sheet is a table of the different transformations we have. Okay, so for example, converting an alkene to an alcohol, converting an alkene to a diol, converting an alkene to an epoxy, converting a alkyl halide to something else by using a nucleophile. When you have your reactions, a table of E1, E2, SN1, SN2, and know that your E2s and your SN2s follow a certain path, right? You're in an E2, you're always pulling off a proton on the carbon next to your leaving group. On your E1, SN1, you always go through a carbocation, so you get racemization or disorder, or especially in an E1, where you can get 1,2 hydride shift, 1,2 methyl shift, and when you have rings, you can get ring expansion or contraction. You're always looking for that 5- and 6-membered ring when you can reorder a carbocation. So those are things that should be on your reaction sheet, okay? And I thought of 3 reactions that might have missed your reaction sheet, so make sure these go on there. For example, we have a way to take an alkyl halide and turn it into an alkane. Okay, it's kind of a side reaction, because when you make a Grignard out of an alkyl halide and then you quench it with something that's more acidic than that Grignard, it turns back into the alkane. For example, if you had an alkyl halide, you added magnesium to it, created your Grignard, and then you added that Grignard to something that has acetylene in it with a hydrogen on it, that hydrogen is more acidic than the sp3 hybridized carbanion, and therefore it's going to deprotonate that and turn that alkane into that, it'll turn that alkyl halide into an alkane, and then you'll have that salt of the acetylene. So that's one of those reactions I think you want to make sure you have in there, because it's kind of important. Some of the other ones are reactions that follow certain rules. For example, cis and trans, okay? You want to follow Zaitsev rule, which is you want to make sure you try to get to the most substituted alkene. Make sure that those kind of rules show up in your special notes. This reaction goes through a carbocation intermediate. Ooh, rearrangement's possible. This one never goes through a carbocation, therefore we only have, to follow our Zaitsev rule. Okay, things like that. Those are the things you would have in your table. Make sure that they appear in your system, and if you're not really clear on it, go ahead and put page numbers, and so you can reread it to answer the question correctly. Okay, so those are the types of sheets I think you should have prepared for the final, and you should be able to have, you know, go ahead and set it up. You have your computer, you have your internet, you have your spare sheets, you have everything kind of ready. And then when you start it, try to start as early as possible, because you might say, oh, only 50 questions, it'll take me 10 minutes. No, it will not. Please start early and take as much time as you need. Okay. Oh, the Grignard reaction is in chapter 12, but we had alkyl halides, didn't we? What reaction did we learn with the alkyl halides? I thought we introduced Grignards in chapter 6, nucleophilic reactions. Somebody put in the thing that Grignard reaction doesn't happen until chapter 12. Actually, that might be true. In 2330 class, we spent a lot of time on Grignards.
I think we, in chapter, I think it was 11, we went from an alcohol to an alkyl halide. We did that, right?
Okay, yeah, and we had a couple different reagents for that. We had phosphorus pentabromide if we want to go bromide, and we have thionyl chloride if we want to go to a chloride. But I don't think, yeah, we might not have done Grignards yet. Oh, alcohols from Grignard reagents are in chapter 12. Okay. I thought it was under reactions of alkyl halides. And that's alkanes is chapter 4. Nucleophilic substitution reaction should have been with alkyl halides. Oh, it's not one of our nucleophiles. Okay. I'm sorry, I seem to be jumping ahead in the book, unfortunately. It is not one of our nucleophiles. Okay. I thought it was one of the nucleophiles we started with in chapter 6, but it's not. So I guess we can push off the Grignard reaction until next semester. Okay. So that being said, this is kind of the review that I'm going to be posting on the internet. If anybody has any more questions that you'd like to see on the internet post, go ahead and put them in the chat now. Otherwise, I'm going to go ahead and save this, close this meeting out, and reopen this meeting to make sure it saves it to the internet. Okay. So go ahead and give a couple minutes on the chat here. Yes, easy nomenclature will be on there. And this video will be posted to my YouTube channel under our 2341 playlist. Yeah. So let me go ahead and close this out and reopen it so that we can make sure this gets posted.